My name is Rolf Bienert. I'm the Managing and Technical Director of the OpenADR Alliance. We actually last week had a really nice user conference in London, sponsored by BIS, or they have a new name now, right? Which I'm not trying to to say right now. Really good session there, because OpenADR has been a part of the smart appliance initiatives in the UK. And one of our big growth areas as an industry alliance, and I should maybe mention the OpenADR Alliance is a non-profit organization, so it's all based on memberships, and we manage the OpenADR standard, and our members, of course, make the products. So again, that being said, EV charging has been a huge growth area for us. When COVID hit, of course, everybody was concerned what's going to happen, but we have in fact seen a huge growth during the COVID years, even in the Alliance, and with these certified solutions for EV charging. But now we're seeing also the ideas for vehicle to grid, V2X, V2G, V2H, whatever you want to call it. Really, for me, it's kind of the same, taking a hold. And as you can hear, I'm German, but I lived in the US for a long time, and the OpenADR standard comes out of California after the California energy crisis of 2001. So the concept is not entirely new here. But let's talk more about like flexibility a little bit. So to set the stage, I think, hopefully I'm not telling all of you what you already know here, but if we look at a typical demand side usage curve, and maybe ignore for a second the red line here. By the way, I apologize for the kind of blurry picture. You can find that in a video behind the link that I have posted here. It's a little explanation video on our website. It's kind of old, but it really nicely shows what flexibility or demand response is. So what you see here in the blue line, it used to be a typical demand side consumption curve, right? So between those two kind of turquoise lines, kind of the peak times during the day, and in particular in warm areas, so like California, for instance, in the summer, but also during the winter time in other countries, depending on the climate. You will have this typical curve here. More in the morning, you start out with a little higher energy consumption for morning heat, morning cooking, and stuff like that, and then it kind of increases during the day, obviously, to be peaking then early afternoon. So this again used to be typical curve in California, and now if we are putting that supply line on here, the red curve, you notice that on certain days the demand would just simply exceed the supply. So as you can see right here in that middle section, of course. So in the 2001 energy crisis that I mentioned, the reserves were mismanaged, and the demand really went through the roof here, went through the supply, and there were rolling blackouts that were necessary to keep everything else running in the state. So of course the Energy Commission said we cannot have that. We can't have rolling blackouts in California. So the idea of a more automated, a quicker communication to the demand side grew very, very quickly. And with that, essentially, you were able to send signals directly to the consumer and request a change in their consumption behavior. So the trick here is to not necessarily force the consumer to do this, but to give them information elements which could either be price information or specific energy consumption requirements or requests rather, and the consumer side, typically through either building management system, these days, of course, cloud-based energy management platforms, and of course, EV charging operators and so on, can then manage the consumption. And you can see here that the curve is flattened, in that high consumption time frame. However, we have been seeing, of course, changes in this demand line here. So renewables and electrification, have been pushing both supply side from like a renewables perspective and the demand side from plug-in charging at home. So you see evening peaks and such. And the curve now is starting to look quite differently. And I think in many parts of Europe, this is already the case also since a while. But this is one of those things that in the US, they call this the duck curve. And if you, let me make this a little bit bigger here. So it basically, if you will, has the body of a duck here and the beak on the right and the tail here. So somebody came up with the duck curve. So again, lots of renewables during the day, but then peaks later on when people get home, renewables go away and you plug in your car and things like that. So again, probably not new to a lot of folks here, but wanted to really set the stage here. So now again, what does OpenADR do? Really quickly only, it's a communication protocol over the internet here. You communicate from a flexibility server that typically sits at a distribution utility, and it can communicate through existing internet to customer sites. And this can be anything really. I mentioned earlier already, building management systems, energy management platforms, EV charging management systems, and so on and so forth. So it can be a variety of systems underneath, also through aggregators, of course. So all of these approaches work here. And as I mentioned in the BEIS PAS standards, the 1878 and 79, OpenADR is in there as that connection A from to the aggregator level there. So let's look at what we had as resources. So it used to be, of course, again, all sorts of different renewables, or I shouldn't say it used to be, it still is, but it's a whole variety of different systems that are out there that can receive, again, these price messages or energy related messages. And we don't specify, how you control the systems. So there were recently discussions with smart homes, of course. You can again have here the OpenADR VEN, so this gateway portion here can be the charge point operator, for instance, or it could even be a car OEM. So we have some members. In fact, Ford Motor Company is on our board of directors, and they are really interested in getting price and energy messages straight to their management systems, also for fleets, but also for private vehicles, and they connect them to different utilities. So this is already happening in the US, and there's both ways. So charging management as well as vehicle to grid here. So what used to be the typical resources were, of course, HVAC, some bigger appliances, typically nothing too small because it's not always worth the effort for the management infrastructure, and then industrial systems from big refrigeration systems to, of course, manufacturing plants in the northeast of the US. For instance, there were a lot of factories that do like melting at specific temperatures and so on. So there's some good stuff there. But now we are, of course, seeing, as you saw in the previous picture, more solar system batteries, car chargers, and so on, that can be really, really good resources. And if you think about it, in a typical home system, home solar system, you have a 10 kilowatt hour battery. At least that's what I found online. Mine at home is actually 7.5 kilowatt hours. And, you know, I can, if I don't run the AC or anything, it will last me through the night, but it's not huge here. Whereas car batteries, you know, can have a much bigger range. I saw numbers of about 100 kilowatt hours, 110 in some of the, I believe in one of the Mercedeses that I found. I believe the Tesla battery has something like 85 kilowatt hours. So you can see that there is a much larger resource all of a sudden available when we talk about the demand response, the flexibility on the customer side. And it's really low-hanging fruit for us, because these systems are all already connected via apps, via control platforms, via customer input on the phones, on the computer, on preset systems. So these are very easy to grab systems out there. So it makes total sense that trials have started, and I think they're going really well. We saw a presentation just last week that actually showed us some really good results for this. And again, there might be concerns, and I have that on another slide, about life cycle of batteries, but we're not necessarily talking about fully draining a car battery here, right? But you can output quite a bit of power from these car batteries with a much smaller state of charge change here, and with that you don't really stress the battery too much. Again, I know some of you will say, well, it's still, of course, loading the battery, so it may over time reduce the life cycle of the battery, but that is something that needs to be determined and figured out what the best approach is. So again, the car batteries are a really flexible resource, and if we use the standards, as you saw before, there is fairly easy access to the power in these batteries. Of course, for those of you maybe not too involved in it, remember, usually you have a charger from the grid to the company, to the car. Now you need an inverter coming back from the vehicle, so there is additional hardware, of course. But these studies that were, I believe, funded also by the UK government, it really showed that the customer can save easily 300 to 1,000 pounds, potentially even more per year on this. And if you take that off the energy cost for charging, the purchase of the vehicle, and so on, it really starts to take the cost down at least a little bit. Of course, again, EVs are expensive, and if it really reduces the life cycle of the battery, that all needs to be factored in. But the studies really showed some promising results on this. And then last but not least, here the two last points on the slide, the owner of the vehicle really has to keep the control here, has to have autonomy or what to do. You need to be able to set, okay, how much of the charge of the battery of the car do I want to make available to the grid. These would be pre-settings that you put in place. You need a certain charge level in the morning to leave the house. You need to have a certain charge level to get home, and things like that. But this so far seems to be very manageable. And yeah, you also have a nice backup for your own home, especially if you also have a solar, you can really, start integrating that. So like everything new, there are some items that certainly need work. So, what is the interaction between the house and the EV and the grid? So there's a lot of things that still need to be figured out. As I mentioned already a couple of times, life cycle implications for the battery. There is also, I haven't seen it too much here yet in Europe, but in the US, there are questions about power quality. If you have, more and more fairly high-powered inverters that push power into the grid, quite obviously that power quality is not quite up to par with typical generation. So, does it need some periodic grid code adjustments in those? And very important, of course, acceptance of all of this by an EV owner. We just talked about that last week at the conference, that there is not a lot of good marketing that we have been seeing, about smart grid, about flexibility, about a lot of the things that were mentioned before, and that there might be some individual marketing efforts, but a general education in the entire smart grid space. So this is not only UK or Europe or US or anywhere, but in its entirety, I think there needs to be a unified message on this, to get the people to accept these type of interactions with the utility here. So still some work to be done here that we have to think about, but that's the the innovation that we need and that the companies can make their money with at the end of the day. So all solvable solutions. And this would really create a nice big new resource here, just using that same chart that I showed before. And really, it is now the time to start this, right? We do want to start the marketing, as we just discussed, and we can help mitigate climate change. Using these resources, less peak power plants, flattening the consumption, really moving more towards the peak renewable times. And in one report, I saw, and I see that number quite a bit, that by 2030 there could be 250 million EVs globally. So even if you take only a 50 kilowatt hour battery here, that's a pretty big number on kilowatt hours that would be available. Of course, again, you don't want to deplete the entire battery, but overall, it's just very, very fast, accessible, short-term, balancing power that you can use there. And like we said before, the technology is there. Typical simple setup here, again depicted on the right, and we have actually seen also good results in some smaller fleet applications that are already using this since quite a while. So glad to see that the UK has been doing a lot of these trials. And I think it's really, one of the, it could be one of the disruptors here to make this, to make the energy transition work at the end of the day. Again, work to be done, money to be spent, but also I think, for the companies out there, definitely money to be made here as well. So I think this was my last slide. Jordan, I give it back to you for any questions that there might be.
Perfect. Thank you, Rolf. I know how busy you are, so it is appreciated that you are you're here with us. If anyone in the audience has any questions, then do let us know. I'm going to kick it off. During a recent Investors Day, long-term V2G skeptic Elon Musk was asked about bidirectional charging. While his position appears to have softened in recent years, he still thinks V2G isn't the holy grail many think it is, with fixed energy storage the better option in his eyes. What would you say to that?
Well, I'm not sure if I should be scared or honored here that you're asking me something that Elon Musk commented on here. But so I think, you know, I would say he thinks, of course, large scale, right? So, and if we are, talking about utilities and overall grid, there needs to be large scale storage as well. And I think later on today there will be some presentations about storage and how that will help. And I'm not necessarily saying that vehicle to grid or vehicle batteries would completely replace that storage, right? So I think we're talking a little bit about two different sides of the same coin here. So they work together, right? So, but car batteries, I think, will not replace the need for large storage eventually. If you really want to use primarily renewables, you got to store the power you make during the day somewhere for the night. I mean, we still have plants running during the night, and to be honest, I have to admit myself, I changed my opinion on nuclear power plants in the last 20 years. Coming from Germany, as a young boy, I heard about Chernobyl, right? And I lived actually only like 30 miles from a nuclear power plant across the border in France. So it was a bit of a okay, is this a good thing? But I think this is now much safer, and really, if you look at even cost of life and everything. Anyway, that's a completely different presentation, I suppose. But again, if you really want to make the most of large scale renewables, you got to store it in large storage facilities, and that's not the electric vehicle. So no. I think the electric vehicle, however, can be really like instrumental in like flattening the the curve during the day, right? When energy is available, but it's changing, right? Solar is obviously one of the quickest changing renewables. It can go up and down, some clouds move through. Wind is probably a little slower in changing, and got the thermal and all this good stuff, which is a little more solid. But you do have these fluctuations on both the supply and the demand side. And a good example, folks should maybe, if they're interested, should look it up. Hawaii. So Hawaii, for us Europeans here, we might not know that much about them, but they have zero energy resources but renewables, of course. So all the energy generated on the Hawaiian Islands was literally brought there by ships. So it's all diesel oils, brought there by ships, and as you can imagine, extremely expensive. So kilowatt hour 50-60 cents and stuff like that. So they really pushed on moving to all renewables, and they have a lot of wind, they have a lot of solar, of course, and things like that. But yeah, I mean, they need that demand side to follow the grid, right? And that's really where these resources shine, right? So sorry, I kind of a long answer, but I think it was important to separate that a little bit.
Yeah, definitely. And I totally get what you're saying in terms of we're already seeing that demand side in the UK through time of use tariffs that even work with smart vehicle chargers. So it seems like we're at the beginning of those steps, but then V2X is the natural next step. Although I would say, could one of the major barriers to V2X be down to the industry being too slow to adopt the technology? We've been talking about it for a long time, but it's only in these last 12 months or so that the UK government has really gone all in. And like, just speaking from a consumer point of view, many have already adopted electric vehicles, or commercial buildings have installed their EV infrastructure. A lot of those places that have existing EV chargers may not support bi-directional charging. So how do we entice these people in the future to upgrade those chargers so they support the V2X technology, given the high initial outlay of installing a charger?
Yeah, of course, and it's always, you know, the money, you know, the return of investment is always the biggest question. And coming from the good old demand response flexibility side, you know, when we're talking about HVAC, just controlling an HVAC system to save like a kilowatt, you know, is like really difficult to kind of, you know, derive an ROI to that. But I think, you know, the utilities, I believe, need to start kind of thinking more, you know, future oriented. And that's not a diss on them, right? I'm not saying that they're not, you know, trying to come up to speed, but you know, it is an industry that is fairly, that has to be very stable, right? You know, I mean, I come from telecom myself, and you know, kind of ages me a little bit, I guess, but when I became a telecom technician at the time in the 80s, the killer app was a fax machine, right? So that was sort of the, wow, this is the thing, right? And see where we are now. And yes, of course, it's quite a few years later, but still, you know, there's a huge, I mean, it's just such a crazy technology development in these last decades. And I think we're seeing it here as well. And the utilities need to, and then a lot of them are doing it, you know, need to look forward and see, okay, you know, can we incentivize that? So like, for instance, I am personally thinking that we need to move the whole discussion about grid connection pre-sale of, for instance, a vehicle, you know. So this now gets maybe a little bit, you know, philosophical here, but what we are seeing right now is that, okay, you know, having an electric vehicle is cool, right? So a lot of people like it because it's the thing to do. It's kind of hip, and you know, in California, of course, like everybody wants to buy a Tesla and an EV and stuff like that. But there's no talk really about, you know, smart charging before that. Often it comes later, right? Afterwards. And the Ford Motor Company, for instance, as I mentioned, they're board members, so I know from them that they consciously first sell the vehicle, don't tell them about any utility programs, and then let the customer get used to it for a month, right? And then they go back to them and say, oh, by the way, the utility you're connecting to offers you this kind of cash back, you know, better energy rates when you when you let them give you ideas about charging times and things like that. And you know, just to not scare the customer too much, kind of interesting, right? So, but I think, you know, as the customers become more aware, this becomes an earlier thing, right? So like, if a car is ready to connect to your utility, they will tell the customer, right? If you buy my car, hey, you can get from the utility, you get maybe, you know, just like when you buy a very efficient appliance, right? You might get a bonus from the utility. They might give you a better rate. If you buy my car, because they can control somewhat the charging, they may be more inclined to actually put a bigger power line into your house, right? Because we know that a lot of homes, they don't even have, you know, enough power coming in, right? So there's a lot of incentives that could be discussed. So I think that's really sort of one of the starting points, right? To kind of incentivize people to spend a little more on that, maybe get some tax money back, get some energy bill, reductions and things like that, and a few other perks. So I think that would be the sort of way to think about it.
And in terms of bidirectional charging, obviously they're different. You need a specific charger that can support that. That's, I think, the big issue at the moment that I foresee, in that a lot of the chargers that are being installed now and a lot of the cars that people are buying now just don't support it. How do we get that support?
Yeah, I mean, I think you have to think about the life cycle of technology as well a little bit here. So I think if somebody bought, like, last year, the year before, or even just now, an electric vehicle, will they change to vehicle to grid? I don't know, right? Like you say, I mean, you would have to replace the whole probably charger, and wired in the house as really a resource. So it's completely new installation. Sure, it's doable if there's enough incentive there, right? If the utility or even the car maker offers them a package. I mean, to be honest, inverters are not that expensive comparatively to a car. I think my 5 kilowatt inverter, or lone inverter, not a charger, inverter, from like Victron, for instance, fairly well-known company, is something like 2,000 euros, right? So yes, it's an expense, of course, but in the greater scheme of an $80,000 car, it's a smaller expense. Again, can the customer get that 2,000 back? So if the £1,000 a year in savings on energy is true, 2 years, right, he has that equipment paid for, right? But as I mentioned in the very beginning, after your question, think about the life cycle of the modern technology. It's a sign of the time, right? That people might even lease these cars, right? So in 3 years, they might buy the next one, right? So life cycles of all of this are getting so much faster that it's not like you buy an electric car now and you'll have that for 20 years or for 10 years, right? So maybe we're, if we're saying we need to start this now, I don't necessarily mean that, okay, now we have to like snap our fingers and everybody does it, right? But if we are starting now, maybe in the next cycle, right, we would see then a good percentage of those.
We're still early enough, I think, in a transition that we can capture that inflection point now. I know you are pushed for time, so I'm going to let you go. Thank you so much, Rolf.